This is the fourth video in a series of work solutions for Edexcel GCSE Computer Science to help you revise for Paper 1 for your summer exams. So this video talks through the answers and how to get to the answers for questions 1c, and then your challenge at the end is to have a go at question 2a. So let's have a look again at question 1c. In the previous video we talked through the key words here, so let's go through the solutions. So the first step will be to identify which logic gates we've got. So I would recommend annotating your diagram just to know what these three logic gates are. So we've got an OR gate over here, we've got a NOT gate in the middle, and we've got an AND gate over here. So it's worth trying to remember the easy way to remember these. I think the curvy bit on the left hand side of an OR gate looks like an O, or some people think it looks like a rocket blasting off into orbit, or for orbit. NOT, I think, is the easiest one to remember because one side has not got a blob, the other side has got a blob, or you could just remember a NOT gate only ever has one input and the others have two inputs. And then we've got an AND gate. The shape of an AND gate looks like a D, and you've got a D at the end of an AND gate. Okay, now we've identified what the logic gates are. We need to complete this truth table, and it looks pretty terrifying, but if we decompose it, if we split it down into smaller sections and do them one at a time, it's actually not that bad. So let's do, rather than one row at a time, let's do one logic gate at a time and work from there. So first of all, our OR gate has got two inputs. It's got an input connected to A and an input connected to B, and its output is connected to D. So with an OR gate, the output is going to be 1 if either or both of its inputs are 1. As in, the output is on if either switch is on. So let's just double check if that makes sense with the answers we've already got. We've got two inputs, 0 and 0. Neither of them are switched on, so the output isn't on either. Here though, one of our inputs is switched on, so our output is also switched on. Down here, where we've got another empty space, two inputs, both switched off, both zeros, so our output is a 0. So that's the OR gate sorted. Now let's look at the next gate, the NOT gate. The NOT gate's only got one input, which is connected to D, and the output for our NOT gate is connected to E. So a NOT gate, the output is just the inverse, the opposite of the input. So let's check and see if that makes sense. The output is the opposite of the input. 1's the opposite of 0, 0 is the opposite of 1. That makes sense. Let's go to where we've got a gap. The output is going to be the opposite of the input, so we put a 1 in here. So now we've done 2 out of the 3 logic gates. We've just got one more to go. This time, one input is connected to E, another input is connected to C, and then the output is connected to F. So we're looking at column C and E as inputs and column F as output. For an AND gate, you need both inputs to be switched on in order for the output to be on. So one is switched on, the other isn't, so we've got a 0. Both of our inputs are switched on here. We've got a 1 and a 1, so the output's a 1. And then we've got a 1 and a 0, so we haven't got that and that, so the output is going to be a 0. 6 marks available, 1 mark for each correct answer. The trick here is to make sure you remember the symbols for each logic gate. For the OR gate, you can have either or both inputs as a 1 to get a 1. A NOT gate has only one input, the output is the opposite of the input. And an AND gate, you need both inputs to be a 1 to get a 1 as an output. Okay, so your challenge is now to go away and have a look at question 2a. You can stop the video here and just have a go, or you can carry on watching as I talk through the keywords that you should probably highlight for this. So let's just get a highlighter. Help. Okay, so a delivery drone has an embedded control system. That just means a computer inside the drone that controls how it works. A single purpose computer, only does one thing. The drone has an altitude sensor. Altitude means how high above the ground you are, and it says it reads the distance the drone is above the ground. At this particular moment in time, the distance above the ground is 78 meters, and we have to convert the Denary number 78 to 8-bit binary. So actually, you don't really need to understand this top bit. The important bit is converting the Denary number 78 to 8-bit binary. Then, for 2 marks, you need to, so it says the drone transmits the altitude to the remote control, which displays the value in Denary. Remember, Denary's numbers as we think of as normal, like 10, 11, 12, 100, 39, anything like that. And it says convert the 8-bit binary number, and then we've got an 8-bit binary number into Denary. So it's just converting this 8-bit binary number into a Denary number. And then finally, it says the drone adds the latest sensor value with the previous sensor value and performs an arithmetic shift in order to halve the result. So this looks complicated here, but it's not that bad. You'll need to probably go away and revise and research arithmetic shifts. We've got, so it takes the average of the 2 sensor readings. So we add 2 values together and we do an arithmetic shift to divide it by 2, so you get the mean average. We've got 2 binary values. You add them together, and then it's saying perform an arithmetic shift on that answer, the 2 latest altitude sensor values added together. You've got to divide that by 2 by performing an arithmetic shift. Okay, so I hope this has been useful. I'll go through how to get to the answers to these in the next question, but you have a go first. Thanks for watching, all the best for your revising.